Alright, class. So, which is the carbohydrates. So, I believe you all have read up. So, for carbohydrates, the elements that can be found will be C, H, and O, carbon, hydrogen, oxygen. So, by looking at the name of it, carbo means carbon, hydrates mean water. Okay, so if you see the elements carbon, hydrogen, and oxygen, so since you have carbo and then hydrates mean you have carbon, water, so the ratio for the C, H, and O will be C and then H2O. Okay, if you realize there is a C and then the ratio is H2O, which stand for water. Now, for carbohydrates, okay, that we're going to see here is mainly the three types here. Okay, or we can say is a monosaccharide, disaccharide, and polysaccharide. So if you have read up, saccharide means sugar. Alright, so saccharide means sugar, mono means one, di means two, then poly means three. Okay, so what you have to know about monosaccharide, disaccharide, and polysaccharide is the definition of it. Okay, what are they? And then the second thing is their properties and the types of this sugar. Okay, so every type here, for example, monosaccharide you have three types. Okay, or disaccharide you have three also. So polysaccharide you have few, and then how is it formed? Okay, so if you have read up, that's good lah. So if you haven't, let's see. Okay, so for monosaccharide, okay, it is also known as simple sugar. Even though the name is simple, but it's not that simple. Okay, this monosaccharide, the most simple one, will have 6 carbon. Okay, 6 carbon. Yeah. So if you see the formula, C6H12O6 is to the ratio. Just now you see the carbohydrate the ratio is C1H2O1. So if you have C6, you have to multiply the H with 2 to fulfill the formula or the element found in carbohydrates. Let's say it's not C12, H12, C6H12O6. Let's say it's a C5, okay, or C5H10, then it will not be the carbohydrates. So in order to become carbohydrate or in a group of carbohydrate, it must follow the ratio. C is 1, H is 2, O is 1. Okay, and it only has 3 elements, no other than that. If you have another extra F, fluorine, or you have chlorine, then it will not become monosaccharide, or it will not be the carbohydrates. Okay, it must follow only C, H, and O. So if you have read up also, okay, you will know that there are three types of monosaccharide that you must know. Okay, actually there are more, but these three is the must know. Okay, we have glucose, fructose, and galactose. They are all 6 carbon sugar. Just that when you or when they arrange, okay, the six carbon when they arrange in fructose and glucose and galactose, their arrangement is a little bit different. Okay, so later on I will show you how is it different, or you can just google it, okay, to see how glucose, fructose, and galactose different in the way of in the way they arrangement, okay, or the molecule arrangement. So that is extra, you all don't need to worry about it. Okay, so now we see glucose. So glucose is the most common one, and we know that glucose comes from photosynthesis, okay, from the plant. After photosynthesis, the plant produce glucose. So glucose are sweet tasting crystalline. What is meant by crystalline? Mean it will be a crystal like what you have in the kitchen, okay, where you will make your drink. That is a solid. That solid is actually one crystal, if you notice. Okay, it's a very clear, it's a crystalline thing. Okay, so and it is soluble in water. So monosaccharide, all the monosaccharide can dissolve in water. Okay, we skip this. Okay, like, so how about disaccharide? So the word di mean is two. Okay, what is two there? So two means you have two monosaccharide that Okay, and then when they combine, they remove a water molecule. Okay, I will show you how it is combined, and then the water is removed in protein later on. Okay, in the slide for protein, I will show you a simple a more detailed one, but for now we just understand first, okay, or we memorize first how the two monosaccharide combine and then they remove one water. So this process is known as condensation. So if you can see here, the six sugars, we can use a hexagon to represent the structure. Okay, so the hexagon represent the monosaccharide. So one monosaccharide, the second monosaccharide, condensation, and then you have disaccharide. Okay, so just now we have three types of monosaccharide. So if you see the monosaccharide glucose, another monosaccharide fructose, okay, when they combine or when they undergoes condensation, they become sucrose. Now this one you must know, okay, must know what plus what equals to what. Glucose plus fructose, it must be sucrose. Then you see the bonding here, the bonding here is formed. Okay, so when the bonding is formed, one water molecule is removed. Okay, and then if you do mathematics, yeah, C6 glucose have 6 carbon, fructose have 6 carbon. If you add up, it becomes 12. So you see the formula for disaccharide, C12. H12 plus 12, 24. But here you have only 22. Why? Why you have 22? Because here, alright, H2O, H2H, 2 atom H is already in the water. Then you see the O is supposed to be 12, now it's only 11. Okay, 11 means something, one of these oxygen is become, I mean, it already combined with water. Okay, so you got it. So that is condensation to form a disaccharide. So generally the formula for disaccharide will be C12H22 and O11. Okay, so another name for the disaccharide is also called the double sugar. So now if you can form the disaccharide, means you can deform or breaks. So when we want to break the disaccharide, you have to add water. Okay, add water, because when you form, you remove water. Of course, when you go backward, you must add water, and then the process is known as hydrolysis. Okay, here we cannot see the word hydrolysis, but in your slide, yes, you have, I have. Okay, so hydrolysis means remove, add in water. When you add in water, it's not easy as that you just add water. In chemical or chemical reaction, yeah, we add water means we put some acid to it, a dilute acid. Okay, a dilute acid. That experiment we will do, okay, soon. Okay, or maybe I will share you a video later on how we do the experiment. Okay, now for just like monosaccharide, disaccharide, disaccharide also is sweet. Okay, and they are in crystal and they are soluble in water. They are more or less like the monosaccharide. Okay, more or less the same, just that they are double sugar. They have two monosaccharide combined together. Okay, the most common one is maltose, lactose, and sucrose. Okay, this is how is formed. Okay, so maltose between glucose and glucose, sucrose between glucose and fructose, and lactose between glucose and galactose. So it's not difficult. The first one is always glucose. Okay, the second one you change. If it's glucose, then it become maltose. Maltose is the grain sugar, can come from malt. Okay, fructose, it becomes sucrose. Oh my gosh. Okay, sucrose, which is the fruit sugar. And last one will be galactose here. It comes from the milk sugar. So all of them will have the water removal. Okay, so next one you will see, yes, polysaccharide. So as for polysaccharide, of course the definition is you have many monosaccharide, more than two. Actually there are more than a few hundreds. Okay, it's not only two or three, it's just more than about hundreds, hundred over thousand. It can be very, very long, depends on their function. Okay, so same process, condensation, all right, and then they will form a very large polysaccharide, means a lot. So this process is no more condensation only. Okay, from the many condensation, the monomers will joins together, and the process of becoming long is polymerization. Okay, this process makes the chain very, very long. Okay, a large polysaccharide. Okay, where your carbohydrates, the word carbohydrates, okay, or the carbohydrate is actually a long chain of polysaccharide. Okay, now polysaccharide, when they undergo the polymerization, okay, every monosaccharide now is called that monomers. Okay, monomers means the building block. So polymerization will form, yes, glycogen or starch. These two we have known, just that the structure we are not so in detail. Okay, so now since we are going to in more detail, we will see how the glycogen and the starch look like. So first we see the starch. Now starch, yes, they are sugar, so that's why you see the hexagon, the red in color one, they are all glucose. Okay, the six carbon sugar, so they join together like a chain, see, so they are called the starch. So their subunit means their monomers are glucose, so they can be branched or unbranched. The one that is here shown here is unbranched. So if you have branched, it will be a more complex one. Okay, so branch one will become the glycogen. Okay, it will have more branches and it become glycogen. So in animals, sorry, in plant, just now starch. Okay, most of the starch will have this unbranched. But let's say they have branch, they have smaller branch. I mean, not that complicated one. They cannot have too complicated. Just simple branch. Okay, because starch is the food for that, the storage of food for the plants. Okay, they cannot have too complicated structure, too much branches. Too much branches will make the energy harvesting very slow. Okay, now next one will be glycogen. Glycogen is in animal, so animal is a bit different. They have more branches. Okay, the link or the chain of glucose have more branches. Okay, more branches because the energy stored in the animal are more complex. Okay, more complex lah. Okay, so they have more branches. Okay, the next one you will see, yes, in the plant also. Okay, the glucose is also form the polysaccharide. The polysaccharide will be arranged in such they are very long, and then in between the chain they have some what we call the supportive, or the one the bond. Okay, the bond between the two long chains to give support. So from this structure is seen is a very rigid one, so it can give the support. As you know, cellulose are the cell wall. Okay, sorry, it will make up the cell wall of the plant. Okay, so when we say cell wall, it need that support. That's why the arrangement is very, very firm. Okay, now next one you will see, yeah, the last one. Okay, the last one in, so you have three, how many three type of polysaccharide: glycogen, starch, and cellulose. Okay, the three, then they are a bit different from each other, but the similarity is they have all the glucose linked together. Okay, last one in this carbohydrate slide, okay, is about reducing and non-reducing. I have to introduce you with that, the new term. Okay, it's not that new, just that we haven't used it on it. Okay, reducing from the word is mean reduce. It can reduce something. Non-reduce mean it doesn't reduce. Means the sugar doesn't reduce thing. Okay, or some chemicals. Reducing sugar means it can reduce. So you see, some sugar act as a mild reducing agent. Okay, so sugar can become a reducing agent. There are two common reagents to test for the sugar. One is called the Benedict's reagent. Another one is Fehling reagent. Actually, they are same. They are, I mean, the name is different, but the chemical inside is the same. Okay, it's different in concentration. So what it's meant by reducing? Okay, if you learn in chemistry, CuSO4, Cu is two positive. Okay, two positive here. By adding a reducing sugar to this Benedict reagent, the sugar in the reducing sugar will change the copper from 2 positive to 1 positive. That's why you will get your brick red precipitate. Okay, before you add in reducing sugar, okay, before you add in, the Benedict reagent is blue in color. After you add in reducing sugar, okay, the power of the sugar is to reduce the 2 positive, the ionic number, yeah, from 2 positive to 1 positive. And then when you change the power or the ionic power of that copper, the color also change from blue to brick red precipitate. That is what you have done so long. Okay, but now we are looking at the chemical formula of it. How is it happen? Okay, now to summarize everything, only all the monosaccharide, they are reducing sugar. All right, monosaccharide, no problem, all of them are reducing sugar. But for disaccharide, we have three, right? We have learned three. So 3 out of 3, 2 is reducing sugar. You can see maltose and lactose, they are reducing sugar. And then the sucrose is not. Okay, sucrose is not reducing sugar. So that's why when you have sucrose and then you have maltose or you have other tose, okay, to know what sugar you have, you just use a Benedict test. If you have glucose, maltose, lactose, fructose and galactose, no problem. The Benedict test will show you brick red precipitate. But if you have sucrose, okay, you will not have brick red precipitate at the end of the experiment. Okay, you have to undergo a hydrolysis first. Okay, how to do hydrolysis? Add water. How to add water? You have to add diluted acid. Okay, diluted acid in order to change sucrose into a reduced sugar. You have to mix sucrose into reducing sugar, then only you can test with Benedict to get the positive test. Okay, to summarize everything that we have here in the slide, this is the one. Okay, so carbohydrate basically divide into 3 types. Okay, and then the 3 types you have to know the example and the meaning. Okay, you just write this into your notes lah. Okay, the characteristic of polysaccharide. Okay, please, we haven't seen this. It is insoluble in water because it's too long, and polysaccharide do not taste sweet. Okay, and they do not crystallize. Okay, that is due to their long chain. Okay, it's understood lah. So last one, if you have time, I mean, if we can get back to school, we can do this in school. All right, the Benedict test. This one is the brick red precipitate. This is the the Benedict blue, the color of Benedict lah, before experiment. So that's all. Thank you. I see you in the next lesson.